This lesson is on related rates. This is section 5-2. Now, you might consider related rate problems the word problems of calculus. They are in some ways. They typically always are word problems of a sort. Now, the steps that you need to follow whenever you're trying to solve related rate problems are the following. First thing is basically to draw a picture of whatever we're talking about. The next is to make a list of all the known and unknown quantities, okay? Because they're going to give you some information. They're going to ask you to find some information. Then you must relate all the variables in an equation. Then differentiate with respect to time. This will typically be implicit differentiation. And then lastly, substitute the known quantities and rates and solve for what they're asking you to solve for. So let's look at an example here. The width of a rectangle is increasing at a rate of 2 centimeters per second, and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle increasing when the width is 4 centimeters and its length is 5 centimeters? All right, so the first step they said to do was to draw a picture. So we have a rectangle here with a length and a width, okay? Next, we were asked to take and put down what we know. All right, so we know the width is increasing, okay, at a rate of 2 centimeters per second. So dw dt is 2 centimeters per second. Its length is increasing at a rate of 3 centimeters per second. So therefore, dl dt is equal to 3 centimeters per second. Now, they want to know at what rate is the area of the rectangle increasing. So we want to find dA dt. And we want to know what dA dt is when the width is 4 and the length is 5. Okay, so that's all the data that they give us. Well, our three unknowns are basically area, width, and length. So how are they related in an equation? Well, obviously, the area of the rectangle is equal to length times width. So this is the equation we're going to use. Now, the next step says to differentiate this equation implicitly. So the derivative of A is obviously 1 dA dt, because we're taking the derivative with respect to time of each of these. Now, we've got LW. This is a product, so we're going to have to use the product rule, okay? So it's first L times the derivative of the second, dw dt, plus the second, W, times the derivative of the first, dl dt. Okay, so here we've taken the derivative implicitly of this equation with respect to time. Well, now we want to simply plug in what we know from over here with all this given information that we had here. So dA dt, well, that's what we're trying to find, okay? L is simply equal to 5. dw dt is equal to 2. So that first term is simply 5 times 2, plus W, which we know is equal to 4, times dl dt, which is equal to 3. So that's 4 times 3. So we got 5 times 2 plus 4 times 3. 5 times 2 is 10. 4 times 3 is 12. Our answer comes out to be 22. And the units, remember this is area now we're talking about, so it's 22 centimeters squared per second. So that is the rate that the area of the rectangle is increasing when the width is 4 and the length is 5. So now let's look at another example that's a little bit harder. In this case, we've got water running into a conical tank, okay, at the rate of 9 cubic feet per minute. All right. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? And they help us out by giving us the formula for the volume of a cone. It's equal to 1/3 pi r squared h. Well, remember what the first step is in solving these types of problems. It is to draw a picture. So here's our conical tank, point down. The radius is 5, the height is 10. So what do we know? We know that the volume is increasing at the rate of 9 cubic feet per minute. That's how fast the water is coming into this tank. We want to know how fast the water level is rising. So we want to know dh dt, okay? Height with respect to time. When the water is 6 feet deep, okay? Well, here's our equation. And notice our variables. We got v, well, we know what dv dt is. We've got h, we know what h is, and we're looking for dh dt. But we got r. So how can we proceed? Because they didn't tell us anything about r. Well, if we go back to our picture here, notice the original tank had a radius of 5 and a height of 10. Now, they wanted to know how fast the water level is rising when the water is 6 feet deep, okay? So when it's 6, well, we don't know what r is, or do we? All right, notice we've got two similar triangles here. So basically, r over 6 is going to equal 5 over 10. Or in other words, r is equal to 3, or in terms of h, it's equal to h over 2. Okay? Because we don't want to just say what r is equal to 3 because we don't have dr dt, but we do have dh dt. So we want r in terms of h, and as you can see, r is equal to h over 2. So now, if I plug in h over 2 in place of r in our volume equation, instead of 1/3 pi r squared h, we're now going to have 1/3 pi. In place of r now, we're going to have h over 2. We're squaring it, so it's h squared over 4 times h, or simplified, it's going to be pi over 12 h cubed. Okay, so here's our equation. Our only unknowns are h and v, and we have all that information over here that we were given, okay? So now, if I take the derivative of our volume equation, I'm going to have derivative of v with respect to time, dv dt is equal to pi over 12, okay, that's the coefficient. Derivative of h is going to be 3h squared dh dt, okay? So here's our equation differentiated. So now, if I plug in our known values, dv dt is over here is equal to 9. So 9 is equal to pi over 2. 3, what is h equal to? H is equal to 6. That's 6 squared dh dt. All right, so 6 squared is 36. Times 3 divided by 12 comes out equaling 9 pi dh dt. So 9 is equal to 9 pi dh dt. So now if we solve for dh dt, the 9's cancel, and if we move pi over, basically we come out with our final answer, dh dt is equal to 1 over pi feet per minute. So that's how fast the water level is rising when the water is 6 feet deep. So when h is equal to 6, dh dt is equal to 1 over pi feet per minute.